Okay, we're looking at direct variation with y equals kx. This is section 7-4. Okay, here's your general form, y equals kx. The y is your dependent variable. Your x is your control variable. And then your k is going to be your variation constant, which we've also learned can also be your slope. That's just our general form. Okay, we've seen this before. The direct variation equations we've seen. Okay, we did the h and the d. That was the height over the distance on the roof. And then the 0.75 was our variation constant. When we did the ball dropping activity, we had the bounce height and the drop height. And let's say that we had a group that it bounced back up to 80% of the original drop height. Okay, that would be your variation constant. And most recently, we did circumference equals pi times diameter. Okay, so this is your dependent variable because it depends on the diameter, your control variable. And then pi, 3.1415, et cetera, is going to be your variation constant. Okay, so here's an example of that first line, h equals 0.75d. That would be that graphed as a line. This would be b equals 0.8d as a line. And this would be c equals pi times d as a line. Okay, so direct variation, the graph of direct variation is always going to be a straight line through the origin. So if we look at our last three examples, straight line through the origin, straight line through the origin, straight line through the origin. They each had just a little bit different slope. Okay? So if we had to graph y equals 1/2 x, well, you know it's a straight line through the origin, so we can start at the origin. Okay, my slope is 1/2. Well, if you remember, slope is rise over run. So I'm going to rise 1 and then run 2. Up 1 over 2, up 1 over 2. Or if I went like this, negative over negative is positive, so I could do that as well. I could go back 1. Sorry, we want to rise -1. So down 1, back 2. Down 1, back 2, down 1, back 2. Okay, then we draw ourselves a line. And that would be our answer. Okay, y equals -3/5 x. Okay, again, straight line at the origin. So I'm going to start, whoopsie, sorry about that. We're going to start here. And I'm going -3 and 5. So if I go down 3, that took care of my negative. So now I'm going to go the right 5. 1, 2, 3, 4, 5. Okay, this can also be written as 3 over -5. Your negative can go top, bottom, or out front, doesn't matter. But we do have to use it in one place. So if I go up 3, then I have to go back 5. Okay, and then draw our line. Straight line through the origin. Okay, -4x. Okay, now we're going to start at the origin again. And we're going to go down 4. Well, I can't stop there, otherwise I don't have any kind of slope. Well, any number over 1 is still itself. Okay? So this can also be thought of as -4 over 1. So I go down 4 for my rise, and then my run would be 1. If I went up 4, like if I did 4 over -1, 1, 2, 3, 4, then back 1. Okay, and there's your line. Okay, 5x, same thing, start at the origin. I'm going to go up 5 over 1. 1, 2, 3, 4, 5, 1. Or 1, 2, 3, 4, 5, 1. Okay. -2 over 1. So start at the origin, down 2 over 1, down 2 over 1. Or up 2, back 1. Okay, pretty straightforward. All right, 7x. Start at the origin, 1, 2, 3, 4, 5, 6, 7. Is that 7? And 1, and 1, 2, 3, 4, 5, 6, 7. And it's off my graph, but I guess you'll draw kind of a straight line. I'll give you guys some rulers so you can draw these nice and straight. Negative 1/5. So at the origin, down 1 over 5. Up 1, 5. Okay, give me at least 3 points when you're graphing these. Okay? All right, 0.75x. Now you could do this a couple ways. You could go, well, that's, 75 cents, that's 3/4, right? So I could go up 3/4 over 1 and do an approximation, or I could change 0.75 into 3/4. Well, the way it becomes 3/4 is this is 75 hundredths, right? So 75 hundredths, which reduces to 3/4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And there's your line. Okay, this will work. It's just that this will get you to a nice spot to count if you change it into a fraction. So negative 0.9x, all right, so 0.9 is read 9/10. All right, that's it. Can't go any farther, but it's negative. So 1, 2, 3, 4, 5, 6. Oh, I'm going off my graph, so I'm going to have to go up 9. It's off my graph again. All right, so let's just change that one. Let's make it y equals negative 0.2x, okay? So then it would be 0.2, which is 2/10, which reduces to 1/5. And we said it was negative, so it'd be down 1, 1, 2, 3, 4, 5. Up 1, 1, 2, 3, 4, 5. Okay? All right, next. Write the equation of the line graphed. Okay, so it starts at the origin. We know it's going to be y equals something x, right? Okay, so we just need to figure out what the slope of the line is. Rise over run. So let's find a really good spot to count. Not so great there, not so great there, not so great there. Pretty close there. Looks like right there. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Rise of 6, run of 5. That's my equation of my line. Okay, I could have also went down. 1, 2, 3, 4, 5. Same thing. Negative 6 over negative 5 positive. Okay? Write the equation of the line. Again, let's find a good spot to count. Looks like maybe here. Yep. So my slope, again, it's y equals something x. It's negative, okay, because it's decreasing in value. And looks like we're going, let's see, 1, 2, 3. So down 1 over 3. Up 1, back 3, same thing. Okay? So basically if it's a negative, it should be going through these two quadrants. And if it's positive, it should be going through those two quadrants. Okay, that'll work for now. Eventually, we're going to move this away from the origin, but it'll work for today's section, okay? Positive is going to go through those two quadrants. Negative, through those two quadrants.